Hi to everyone. In this video, I'm just going to discuss about how to create a linked list using C language. We have already discussed about the concept of a linked list in the previous video itself. Let's recap that concept. A linked list is a linear type of data structure. It consists of several nodes, and each node will have two fields. One is called the information field, and next one is called as the link field. Data which will get stored in the information field only, and link field is just used to refer to the another node. What's the necessity of referring to the another node here is linked list is a linear type of data structure, as we said earlier, and these informations which will get stored in the memory locations wherever it is free. It means these informations which will not stored in a consecutive memory locations. Then how the informations will be stored means the informations which will get stored in scattered memory locations. Scattered memory locations means wherever the space is free, that space which will be utilized for storing the informations. Just for an example, I am saying the memory locations needed for the memory locations for storing the data in the first node may get stored in the locations 2000, and for the second node it may be 3500, and for the third node it may be 6600, and so on. And you just see the memory locations of these three nodes. These are not at all the memory locations in a consecutive way. It means this memory spaces are scattered. For example, the informations for the first node it gets stored in 2000, and for the second node it's 3500, and for the third node 6600. It means there is no relations in the memory locations for these three nodes. Then how I am going to refer these nodes means by means of this link field only. By means of this link field only, I am just going to make one node to be connected to the another node. Okay, so this link field it's nothing but the field which is used to store the address of the another node. For example, here this link field which will store the address of the second node. What's the address of the second node? It's a 3500. So that address which will get stored here. That means if a particular variable which is storing the address of the another variable means, then it would be a pointer variable. So definitely link field will be a pointer variable. And another one thing, you just refer all the nodes in the linked list. If it is having the one more node next to it means, then the link field which will not be null, because it will store the address of the next node. Okay, that's why it can be otherwise called as a next field also. But if you are taking the link for the last node, it would be null only, because there is no other node next to it. That's why the link field for the last node will be null only. And notice one thing, whatever the nodes may be, but every node is having the two fields, as we said earlier. One is the info field and another one is the link field. Info field, the data type of the info field, it can be any type of data. But here I'm saying in the info field, I'm just going to store the informations of the type integers only. And once if you are taking a link, as we said earlier, a link field is used to store the address of the next node. It means link, it's nothing but a pointer. You know very well, if we wish to store the list of items which are all belongs to the different types of data means, then we should make use of the structure. Structure is used to store the list of heterogeneous data. Okay, so in order to create a node, at first we have to define a structure. That's why here what I'm just going to do it here is, at first I'm going to define one structure in the name of node. Is it mandatory to name the structure as node? Means it's not mandatory, but in order to give a meaningful name, here I have named the structure as node. And what are all the two fields which is present within the node is info and link, right? That's why here within the structure I'm just going to declare one variable as int data. It can be mentioned as data, or else you can mention it as info also. Whatever it may be, both are same only. Information field can be otherwise called as a data field. So nothing wrong in it. And of course, a data, it's nothing but an identifier only. It's a name given by the user. And here node is also an identifier, but here node is the name given to my structure and data is the variable. Here data is the member of the node. Okay, and next one thing, here you please refer it clearly. This is a link, right? It refers to the another node only. Okay, so definitely the data type of the link will also be a node only. That's why here we have written it as structured node and asterisk link. Why I am mentioning here as asterisk means because link, it's a pointer variable. Okay, why I'm writing here as a structure node means because it's just pointing to the another node. So definitely the data type of the link will also be node only. That's why here we have written it as structure node. Okay, then you can close the curly braces, put semicolon. Once again, I am saying in order to store the a list of heterogeneous data, we can make use of this structure. As we are going to make use of several nodes, here I am naming my structure as node. And here I am defining two members for my structure. One is the data and next one is the link. The data type for the data field is integer, since I am just going to store the integer type of values in it. And link is the field which is going to refer to the another node. That's why here I have written it as structure node. Okay. Then you can close the curly braces, put semicolon. So after doing these things, what I'm just going to do it here means I'm just going to create one object for my structure. How I'm just going to create an object? I'm just going to create the object for my structure as a pointer only. That's why here I'm writing structure node asterisk start is equal to null. What's the necessity of mentioning here as null means initially I'm creating one object for my structure node and initially I'm just assigning it as null. In order to avoid the garbage values, I'm just initializing that start node as null, because initially if the linked list is empty means definitely the start would be null. Okay, we can call it as a start, or else it can be otherwise called as a head. It's nothing but a pointer which is pointing to the first node. So if the linked list is empty means definitely the start would be null. It may be called as a start, or else it can be called as a head also. That's why here I am assigning null to the object start. Okay. Next one thing. So after the creation of the node, we have to create a linked list. How can we create a linked list means at first I'm just going to define one function as void create. I'm not at all passing any argument into the function void create. And within this function, I'm just going to create some object for my node. What are the objects that I'm creating? One is the temp and another one is the PTR, and I'm just going to declare one more variable. It's a variable only. It's not an object to my structure. Here I have just declared only two objects for my node. Okay, one is the temp and next one is the PTR. PTR is used for traversing the nodes in the linked list, and temp it's nothing but the temporary object that I have created for my structure node. Okay, and this variable int num, what's the necessity for declaring the variable num here is if I'm just going to create one node, new node means definitely I should enter the data for it. Okay, in order to enter the data for it, I'm just going to make use of the variable num. Okay, and next one thing, you might have been declared the objects for the structure node. Okay, but you have to declare the, you have to dynamically allocate the memory for it. Dynamically allocate the memory for it means, what's the necessity for dynamically allocating the memory for it means during the runtime only we are going to allocate the memory for it in order to avoid the wastage of memory. Okay, so for such a thing we can make use of the functions malloc, and the next one the functions calloc. These are all the functions we can use it. Okay, and we are having one as the realloc also. Okay, actually a calloc, it's a function which is used to allocate the list of memory locations and some set of memory locations which will get allocated in a consecutive manner. Okay, for example, if I wish to allocate 5 bytes of memory means that 5 bytes of memory which will be allocated in a consecutive manner, that is called as calloc. Okay, and free is a function which is used to deallocate the memory spaces, and realloc is just used to change the memory locations of the previously allocated one. For example, just for an example, I am saying I have already reserved 20 bytes of memory. If I wish to change the size of the size of the memory which was already reserved, means by that time I can make use of real lock. Okay, then what about malloc? Means malloc, it's for allocating the memory, large block of memory. You can allocate it by using the malloc, but it will not be stored in a consecutive memory locations. For example, if you wish to allocate the memory of 5 bytes, means that 5 bytes which will be allocated, and if you wish to create another 5 bytes, means you have to create it again, but it will not be stored in a consecutive memory locations. Okay, that's malloc. Once again I am saying malloc, calloc and realloc. These are all the functions which is used for dynamic memory allocations, but malloc is used for allocating the memory, eh, which will not be stored in a consecutive memory locations. Okay, and next one thing, what's the syntax of malloc here? What's the necessity of making use of malloc instead of using the calloc and realloc? Means realloc is a function which is used to change the size of the previously allocated memory. Okay, and calloc is used to allocate the memory in a consecutive memory locations, right? But here the necessity for reserving the memory space for a node only, because at first we will create a node and then we will assign it to the linked list, then we will create one more node, and we will make that newly created node to be pointed by the previous one, right, and so on. So this process which will be repeated if it is needed. That's why it's very important to create a node at first, and we have to allocate the memory for that node alone. That's why here we are just going to make use of malloc, and this is a syntax for malloc. What's the syntax? Cast type and then malloc, and you have to mention the byte size. Okay, so here what I'm just going to do it here means I'm just going to make use of the temporary pointer here. That's why temp is equal to cast type. Why I'm just going to refer it as a struct node means because I'm just going to allocate the memory. What type of memory I'm just going to allocate means I'm just going to allocate of the type node only. That's why here I am writing as struct node malloc size of. So I should mention the byte size as how much of memory have to be allocated, right? That's why here I am going to write it as size of a struct node. Actually, size of is a function which is used to calculate the size of a particular variable that you are passing into it. If I am passing node means it will calculate the size of the node and that value which will be returned by the size of a function. So if I am passing size of a struct node means that size which will be returned, that means the size of the node which will be returned by this size of function. Okay, and accordingly by using this malloc, that bytes which will be allocated and it will be pointed by temp. Okay, it will be pointed by temp. For example, I am saying you are reserving one memory space, size of the size of struct node, which will enables us to allocate one memory space so as to store the data and the link field. Okay, so and it will be pointed by the variable temp. Next, what I'm just going to do, I'm just going to prompt my user as enter the data for the node. Okay, so in order to get the data from the user, I'm just using scanf %d ampersand temp of data. Okay, so actually this operator which will be called as a dereferencing operator. Oh, why should we make use of this dereferencing operator means if you are going to access the um, members of the structure and if the object is a pointer means then definitely you have to make use of this dereferencing operator only. So that's why here I'm just accessing the member of my structure by using this dereferencing operator. So I'm just calling it as temp of data. Okay, so I'm just getting the temp of data from my user. For example, just have an assumption as a user is typing 1 means 1 which will get stored in the temp of data. And then I am setting temp of link is equal to null. So here I am setting temp of link is equal to null. Okay, then I have to check for the condition whether the start value is equal to null or not. Here I am going to check for the conditions whether the start value is equal to null. If it is equal to null means then I can have an understanding as linked list is empty list and the newly created node will be the first node in my linked list. That's why here if the start value is equal to null means I'm just going to say start is equal to temp. So it means I'm going to say start is equal to temp means the start which will also point to the temp. Okay. So in case if the start is not equal to null means then your program control comes to the else part where I am just going to say ptr is equal to start. Okay, why I am setting PTR is equal to start means initially PTR which will be equal to null and then I am going to set PTR is equal to start means PTR which will point to the first node in your linked list. And these are all the code which is used to traverse the several nodes of your linked list. What I am writing here, while PTR of link not equal to null. What it means, while PTR of link not equal to null means, just have an assumption as I am having several nodes. For example, here I am having the 3 nodes. Okay. Here I am having the data 1 and 2 here and here I am having 3. Okay, so initially if I am setting PTR is equal to start means PTR which will point to the first node. And then I am checking for the condition in the while loop. While PTR of link not equal to null, PTR is pointing to the first node. PTR of link refers to the second node. If the say link is not at all equal to null means then the program control enters into the loop. Within the loop what I am writing here PTR equal to PTR of link. Now actually PTR is referring to the first node. If I am setting PTR is equal to PTR of link means what it means? I'm just going to refer the second node. So it means I will have PTR equal to PTR of link refers to the second one. So it means it refers to the second node means then the PTR which will point to the second node. Okay, then again the program control comes to this place and it will check for the condition whether PTR of link is not equal to null or not. Yes, of course, the PTR of a link for the second node is also not at all null. That's why as the condition true, programs controls enters into the while loop, and here we are going to execute the statement PTR equal to PTR of link. PTR equal to PTR of link means it refers to the third node. Okay, and then again it program controls comes to the while loop. Now the PTR is pointing to the third node, and it refers to the PTR of link means it refers to the null only because there is no other node next to the third node. So the condition failed. By that time, the program control comes out of the while loop, and by that time we are just writing the statement PTR of link is equal to temp. Okay, so now what we are going to write it here means PTR of a link is equal to temp means we can erase this one, and here we can include the newly created node. It's a newly created node. Just have an assumption as you have created one node with the data 4 means that node which will be inserted here. Now can you understand as why I have written this code here? It's nothing but this is a code which is used to make my pointer to point to the last node. Once the pointer reaches the last node means I'm just making my program control to comes out of the while loop. By the time I'm setting PTR of link is equal to temp means the newly created node is temp and it will be pointed by the last node of the linked list. It means I'm just inserting a newly created node at the end of my linked list. I'm just writing it as LL. Okay, then you can close this else part, then you can close this void create. I hope now you got a clear idea about us how to create the nodes and how to insert that node into the linked list. Okay, and next one thing, in order to check whether the newly created nodes has been properly inserted into your linked list or not, you have to see the informations which is present in your linked list. No, for that purpose here I'm just going to define one more function as display. There is no return type for this function, that's why here I have mentioned it as void. Okay, just for traversing the several nodes of my linked list, I am just going to create one pointer as PTR. So that pointer which is used to traverse the several nodes of the linked list only. That's why the data type of this PTR must be struct node only. That's why here I have written it as struct node asterisk PTR. Okay, and then I'm just going to check whether the start is equal to null or not. If it is equal to null means I'm just going to print the messages list is empty. Else, if the start is not at all equal to null means, then what I'm just going to do it, I'm just going to do the display operations. So I'm just first going to say ptr is equal to start. Whenever if you are going to do the traversing means, you must start it from the starting only. Okay, that's why here I am setting it as ptr is equal to start. And then I am setting while ptr not equal to null, you can print the data, right? So that's why here I am writing printf percentage d backslash n ptr of data. So once if I have printed the data for the first node means, then I should make my pointer to point to the next node. In order to make my pointer to point to the next node, I can write it here as ptr equal to ptr of link. Okay, that's why it will refer to the next node. So then after doing this one, again the program control comes back to the while loop and checks for the conditions whether the ptr is not equal to null. If it is not equal to null means, again our program control enters into the while loop, and it will execute the statement. It means it will print the data for the second node. And then when the program control executes this statement means, that is ptr equal to ptr of link means, the third node will be referred by the ptr. So this process which will be repeated again and again until the PTR value is equal to null. When the PTR value will reaches the null value means, once the PTR is reaching the last node of your linked list means, definitely then the PTR value would be null. Because while coming to the last node, the statement will also be executed. ptr equal to ptr of link means, if it is a last node, a ptr of link will also be null. Okay, so definitely ptr value will be changed as null. So yeah, again by that time the program control again move to the step where you have written while loop. There it will check for the conditions, but the conditions will be failed because ptr will be equal to null, so it will comes out of the while loop. Okay, then you can close your while loop, then you can close your else, and you can close your user defined function display. And that's all. Next one, you have to call these functions in your main program, because execution starts with the main functions only. Okay, so here we are writing void main int n. N it's nothing but a temporary variable. Just for getting the choices, I have declared the variable n. Then clr for printing the screen. Okay, sorry, clr for clearing the content of the screen. Then I'm using the do while loop here. Within the loop I have written printf enter the choice. 1 is for create, 2 is for display, and 3 is for exit. Okay, then I'm getting the choices by using the variable n. So scanf percentage d ampersand n, and I'm just passing this variable into my switch statement. So switch of n. Case, in the case 1 I'm calling the create, and in the case 2 I'm calling the display method function. Okay, so if the value of n is equal to 1 means create will be executed, and if the value of n is equal to 2 means a display will be executed. Okay, so this process have to be repeated again and again until the user is typing the number 3. That's why here I am making use of the do while loop. Okay, So when the user is typing the number 3, and then if the user is pressing any other key means next to the number 3 means definitely executions will get stopped. Okay. Because what's the reason is, here I have given this do while loop will be executed when the value of n is not equal to 3. If it is equal to 3 means the program control comes out of the do while loop. Next to the do while loop, I just kept only one statement here, is get ch. Get ch is a function which is used for getting a character from a user. It can be of any character. Even if you are pressing this space for that space will also be considered as a character. So definitely after typing the number 3, if you are pressing any other key, automatically the executions which will get stopped and your program control which will return back to your input screen. Okay, so this is about the program. I hope every one of you got a clear idea about us how to do the program. So once again I am saying what are all the things that we have discussed so far. Means we have discussed about us how to create a node, how to insert a node at the end of your linked list, and then we have discussed about us how to display the several nodes of your linked list. Okay, I hope every one of you got a clear idea about how to create a linked list using C language. It's a task for you. Kindly do this program, execute this program. In case if you are facing any problem in this program means, kindly let me know. I am ready to clarify your doubts forever. Thank you. Thank you so much.